We're now going to continue and look not at probabilities, but look at percentiles, and actually do the same sort of problems in reverse. We know a probability, we'll find a value, and this example here will show you how that's done. Okay, and we'll actually just do 2 of these percentiles. You can work out the third yourself for practice. Alright, assuming that IQs are normally distributed with an average IQ of 100, a standard deviation of 15, find the following percentiles. Alright, the 90th, the 99th, and the 30th. We're going to do just the first, the 90th, and the third, the 30th percentile to show you both sides of the distribution. Alright, these probabilities, or problems rather, start with the z distribution, and once we have what we want on the z, then we go to our particular distribution. In this case, the distribution of IQs, standard deviation, the mean of 100, standard deviation of 15. Alright, remember 0 point on the z is the 50th percentile. Alright, it's 50% below that, 50% above. So the 90th percentile, alright, that's what we're looking for here, is some number above that. Okay. Alright, since there's 50% below the middle of the distribution, below 0 on the z, from 0 to the 90th percentile then is 0.4. Alright, it's 0.9, 90% minus 0.5. It's 0.4. So it's this value that we're going to look up in our tables. Alright, so we're going to go to our z tables, look for a probability 0.4 or very close to 0.4, and that'll tell us a z value. And from that z value, we can go back to the particular distribution that we have here. Alright, so let's go to the normal distribution and look for 0.4. Alright, so this is in numerical order here. Alright, that's the closest value I can find. Let's see if I can scroll a little bit. Okay, so we're on the 1.2 row in the 0.08 column. Alright, so this z value is 1.28. And we're now going to move that down to the distribution of IQs, or our assumed distribution. We would need a version of this formula here, which can be rearranged so that x is mu plus z times sigma. It's the x that we're looking for. X is the limit. The mean of this distribution, 100. The z value is the 1.28 times the standard deviation 15. Okay, and the answer to that is 119.2 for an IQ. In actual fact, I've never heard of an IQ with a decimal place, but anyway, you get the idea. Alright, next one, 30th percentile. Same basic information. So you start with the z distribution. The middle point is the 50th percentile. We're looking for the 30th. Alright, 30th has got to be below the 50th, the middle, so we'll draw that here. 30th percentile is such that 0.3 is below that, 30%, and the probability of getting between the 30th percentile and the 50th percentile, of course, is 0.2. It's this value that we'll go to the z tables and find the z value for. Alright, 0.2. Well, sort of a toss-up, but this is the exact closest. Alright, 0.1985 is 0.0015 away. The other z value, the other probability, 0.2019, is just a little bit further away. So anyway, we're going to use this as our percentile, 0.52. It's 50 row, 0.02 column, so our z value is 0.52, but for the fact that it's on the lower side of the normal distribution, so it's a negative 0.52. and that's very important, which is why I did the 30th percentile here, not worry about another number above 50. Okay, and now we're going to translate that back to this particular distribution using the formula x is equal to mu plus z times sigma. Mu on the distribution of IQs is 100. Sorry, no plus here, that's the biggest mistake. Minus 0.52 for the z value times the standard deviation of 15. And that gives us a value of 92.2 for the 30th percentile of IQs. Of course, assuming that my standard deviation of 15 is correct. It's likely to be something different. Alright, and that's all we'll need to do on percentiles here, and that's the end of this video.